welcome to my channel Euclid Mathematics. Today I'm here one of the previous year question from GATE exam, which is from Linear Algebra. This is my second video on Linear Algebra. If you want more video, you can see videos on my playlist. So this question asked in GATE 2019. It is for 2 marks. It's a very easy question. We just need to know little fundamentals only, the basic concept about linear algebra. Okay? So here matrix M is given. So let's read our question. So matrix M is given. So 0, 1, 2, 0, 0, 0, 1, 0, and these remaining 2 rows. Okay, and we have to find out which one of the option is correct. Okay, so it is a single correct option. Okay, so M has, first option says that M has no real eigenvalue. Second option, it says that all real eigenvalues of M are positive. Third option, it says that all real eigenvalue of M are negative. And fourth option says that M has both positive and negative eigenvalues. Okay, so we have to figure it out which one of the option is correct between these 4 options. Okay, to our matrix. Okay, now we can see here in our matrix, it is some special type of the matrix because some of the elements are repeating here. Okay, they are similar to their transpose. Okay, so you can see here their diagonal element also 0. Okay, and if we take transpose 0, 1, 2, 0, so we get the matrix M itself. Okay, that means M which is equal to matrix M transpose. Okay, so transpose and that matrix are similar here. Okay, so how we can solve such a questions in NET exam, GATE exam, or SET exam, or in or different other examples. Okay, so let's go for the solution. We see how that answer easy it is here. Okay, so let's go for the solution here. So we have given a matrix which says that A transpose which is equal to A. Okay, and when we have matrix A transpose which is equal to A, then we say that that given matrix which is a symmetric matrix. Okay, this is the standard type of matrix. Okay, symmetric matrix, it has special property that matrix and its transpose are equal. Okay, so that means given matrix M which is a symmetric. Why symmetric? If we take the transpose of M which comes equals to M. Okay, so both are equal here. So if matrix are symmetric, then always remember it is always diagonalizable over real, and it has always real eigenvalue. Okay, so if that matrix is having real eigenvalue, then our first option it says that M has no real eigenvalue, which is wrong. So we cannot say about it. Okay, so we can say about that first option is wrong. Okay, M has no real eigenvalue, but we got the symmetric matrix has a real eigenvalue. Okay, now next go for the next. We can observe here their diagonals are 0. Okay, diagonals are 0. That means their sum. Okay, diagonal means here diagonal element 0, 0, 0. All diagonals are 0. That means trace of a matrix M. Trace means addition of a diagonal. Okay, trace of matrix M is a 0. If trace is 0, and we know that sum of eigenvalue which represent trace of a matrix. Okay, we know that trace of a matrix can be represented by or equal to sum of eigenvalue. Okay, so if we add that diagonal elements, we obviously get the trace as a 0. Okay, if the trace is 0, that means all the sum of eigenvalue are 0. Okay, and we know that all addition of all positive eigenvalue, it never possible 0, or addition of all negative eigenvalue, it never possible 0. Okay, that means all real eigenvalue are positive or negative. We are not sure about it. Okay, because of that, if a trace is 0 or sum of eigenvalue is 0, then we cannot say eigenvalue are positive, because all positive eigenvalue never 0. Okay, and all negative eigenvalue are also never 0. So that means option B and C eliminated here. Okay, so A, B, C are wrong. That means option D is right. But why D is right? Because M has both positive negative eigenvalue. Okay, when trace is 0, we know that it is only possible when we add positive number to negative number, then we get the their trace sum of eigenvalue or trace is 0. Okay, so M has both positive and negative value. It is only possible answer. Okay, so it's a very easy question, and answer it is also quite easy, that we can answer just orally only. Okay, we don't have to waste more time for this. But to solve such a question, we need to remember few concepts. Okay, few fundamentals from linear algebra. It is a very easy question. I hope so you all have understood my today's example. For similar example, you can see in my playlist. So thank you everyone. Thank you for my today's lecture.